Hello everyone, hope you all are doing well. So we are going to cover today topic F of weed science. We have already discussed topic A, B, C, D, E, and this is topic F, and it will be the last topic of weed science. So this will be the last topic of weed science. So today, first of all, we are going to discuss how to calculate weed index. How will you calculate weed index? It was asked once, so I will discuss it. In the question, we will be given 3-4 weeds, 3-4 herbicides, their dose, their grain yield. Suppose I am discussing the previous year which was asked. There will be treatment 1, T1, T2, T3, T4. These are 4 treatments. In the first treatment, they have used sulforam. Second treatment, they have used isoprutoran. And third treatment, they have used 2,4-D. In the fourth treatment, it was weed free. They have not used anything. And then they will give you dose and grain yield. The dose of first treatment was 25. In anything they will give you, suppose in 25 ml, 25 gram, but we are discussing here, okay? 25, 750, 500. There is no dose that it is weight free, or they will write something in question to confuse you. 2 hand weeding, in this we have done 2 hand weeding, 1 hand weeding, 3 hand weeding. We need not to give focus on those things. Grain yield in sulforam was 50 200 kg or something, kg, gram, anything. We all know how to convert units. 5,000, 4,500, and the weed free yield was 5,500. So what is the formula of calculating weed index? It is weed free grain yield minus applied weedicide grain yield. Applied weedicide or herbicide grain yield by weed free grain yield into 100. This is the formula, must remember it, and it is not a tough formula, it is easy one. Weed free grain yield minus applied weedicide grain yield. This is weed free grain yield, that is grained without any use of herbicides or weedicides, and this is after grain yield after applying herbicides or weedicides by weed free grain yield into 100. So in the first case we will see in T1, what is the weed free grain yield here? This one, weed free grain yield is 5,500 minus what is applied weedicide grain yield. First of which case we are doing T1. This is T1 of sulforam. This is 5,200 kg by weed free grain yield, that is 5,500 into 100. When you will calculate it, as the answer we will get is around 5.5. This is approx, I am not calculating it. We will get around 5.5. You will see after calculating. So this is for T1. Now moving on, it's for T1 is 5.5. Moving on to T2. T2. So weed free grain yield is the same, and here it is 500, 5000. So it will be 500 by 5500 into 100. So in the second case, the answer will be, instead of 5.5, in second case we will have 9, approx 9. I am not calculating it properly. I have calculated it just now roughly. Just before starting the class, I have calculated it roughly, and it was approx 9. You calculated. So in T2, what is the? It is 9. With index is 9. In the same, we will go to T3. So it will become 4500. And when you will calculate the T3, your answer will be around 18 approx. 18 approx. So T3 is 18. So I hope you understand it. How will you calculate weed index? So these three, the weed index of these three are this. Now in the question there will be given, so which should be applied in the field, which we decide should be applied in the field. So from here we can see, the lower the weed index, that herbicide or weedicide we will apply. So the lower weed index is here of sulforam. So in the field we will apply sulforam. Okay, you all understood it? This was easy. Okay, I hope you all understand it. For any queries you can comment. I can teach you many times. I have no worries in teaching. And when you like the videos, when you subscribe it, when you share it, these things appreciate me to do more. As you know, I have started from class. I have had nothing. And the time I am recording this video, I have only 20-25 subscribers. So I am not complaining anything. I am starting from class. I will complete the course, and I will start another courses also. That is different thing. Now we should focus on weed index. So this is how you will calculate weed index. Hope you all understand it. Weed free grain yield minus applied weed grain yield of these three into 100 divided by weed free grain yield into 100. I hope you understand how to calculate weed index. These are easy. Now moving on to next topic. They have asked sometimes about decoy crop, trap crop, sometimes catch crop also. So we will discuss it here. What is decoy crop? Decoy crop. It is a plant that stimulates germination of seeds of a parasitic plant. Germination of seed of a parasitic plant such as witchweed. Witchweed is an example here. The biological name is witchweed is trig species. But stimulate germination of seed of parasitic plant, but it is not susceptible to infection by parasitic plant. So what we can see here, although it stimulates germination of parasitic plant, but it is not susceptible to infection by parasitic plants, and it helps us in reducing soil weed bank. What is soil weed bank? The seed population of weeds. Soil weed bank of parasite in soil So a susceptible crop can be planted with less interference by parasitic plants. I hope you understand it. It stimulates, what decoy crop does, it stimulates germination of seed of a parasitic plant. But it is not susceptible to the infection by the parasitic plant, and it helps us to reduce soil weed bank, the seed population of those weeds of parasite in soil. So a crop, it reduces the crop when it is susceptible, as the soil weed bank will be low. It will not be interfered by the parasitic plant. For example, you can use here, we plant Celosia argentea in sorghum. Crop between sorghum suppose we have grown 2 rows sorghum, in between we can grow Celosia argentea as it is a decoy crop. So this was all about decoy crop. Hope you understand it. Keep making notes. If you will write these things, you will understand it more easily. Now moving on to, what is trap crop? As the name suggests, trap crop. It is a plant that attracts agricultural pests, usually insects, from nearby main crop. So what it does, it can save the main crop from the pest without the use of pesticides, because these trap crop will attract the agri pest from the nearby main crop to them. So we don't need pesticides when we use trap crop. It is simple saving them. It is simply saving the main crop by providing the pest with a crop more liked by it. Suppose here is the main crop. Suppose one pest is infested here. So we will give a crop that is more liked by pest. So what pests will do? They will move themselves or move to the more liked crop, that is the trap crop from the main crop. So what trap crop will attract the pests and the main crop will be saved. This is what trap crop is. Hope you all understand it. For example, you can give here alfalfa planted in strips of cotton, planted in cotton. So what alfalfa does? It saves cotton from legus bug. Okay, it's a kind of bug. It saves cotton from that, as the bug likes more alfalfa. So it will move to alfalfa, and the main crop, which is cotton, it will be saved. This is all about trap crop. So you can now find the difference between both two. What decoy crop do? They take care of parasitic weeds. Decoy crop take care of, let me rub it. Decoy crop take care of parasitic weeds, plus trap crops take care of pests. Here trap crops, decoy crops, act as stimulator that stimulates the germination of or stimulates the parasitic plants. But here the trap crop acts as a host of for pests. Decoy crop of not susceptible to concerned pest or concerned weed. They are not susceptible, as the concerned weed will not damage it. But the trap crop is susceptible to weeds. Susceptible to pests. The pest will attack it, but it is giving itself. It is just giving his life for the main crop. It is giving everything it's produced to the pest so that the main crop remains safe. So it acts as a bodyguard. Trap crop acts as a bodyguard. So this was the difference between trap crop and decay crop. Now moving on to catch crop. What catch crop is? Catch crop. It is a fast growing crop. That is grown between successive planting of main crop. Hope you all understand it. Suppose you are growing main crop, for example, radish in vegetables. Suppose you're growing one vegetable and then we're harvesting it and we need to grow another vegetable. So it is grown between the harvest of one crop and between the end of harvest and before the and it is harvested before the germination of other crop. So that is what catch. It catches both the time difference, the time remaining between each catched. So it is type of succession planting, and what it does, it makes more efficient use of growing space. Makes more efficient use of growing space. And these are mainly grown to prevent minerals being flushed away from soil. So these are grown so that the minerals in the soil remain and they are not flushed away. As hope you all understand it here. So I don't think this was tough thing. It is a easy one. I hope you all understand it. Now moving on to the next topic, that is residual toxicity of herbicides in soil. Residual toxicity of herbicides in soil. What is residual toxicity? The herbicide's residue remain in soil. To what problems it causes? It has been asked in previous years, so I'm discussing it in detail, and it can be asked in the future also. It injure sensitive crops in cropping system. It can be absorbed by succeeding crops. The crops grown after the other crop in which we applied herbicide, the next crop grown after that can absorb these herbicides, and residues can be accumulate in the succeeding crops in high amounts. So the build-up rate is so fast, the amount we use herbicides in high amounts, so the build-up rate exceeds the rate of dissipation. the dissipation rate is slow and the build-up rate of residue is high. So due to the heavy use, the build-up rate is high and dissipation rate is high, and the residual toxicity will never end. It will only increase and increase and increase. It inhibits reduces the growth of microorganism. It can also affect human health. And when consumed through crop produce, consumed through crop produce. You have sometimes seen in news, children are very much susceptible to it. Children face many kind of diseases due to eating of the crops that have residual toxicity, residue of herbicides, pesticides. So these are the problems of herbicide residue. And now how will you manage these problems? Management of problem. First of all, use optimum dosage of herbicide. Optimum dosing. We need to use optimum dosage of herbicides. Leaching of excessive herbicide residue. Leaching of herbicide residue by frequent irrigations. Addition of organic matter. We will add organic matter like F-fermented manure. We will do frequent tillage. Frequent tillage of field to increase degradation of or microbial degradation of herbicide residue. The next thing what you can do, we can use herbicide tolerant crops. In crop rotations. Herbicide tolerant crop in crop rotations. Example, maize, sorghum, etc. We will use surfactants with, you can use surfactants. I think I have taught you about surfactants and safeners. These things are added in herbicides. With herbicide need lower dose. More surfactants within herbicide which needs lower dose. So what this will do, this will increase the absorption of herbicides and the residual toxicity will be decreased. Use of less persistent herbicides. For example, we can use paraquat, diquat. These are less persistent herbicides. When you will, I am writing it here, I hope you can see. When you will use 2,4-D, especially in irrigation, we will try to keep its concentration below 2 ppm. We can use non-phytotoxic, I hope it is visible, non-phytotoxic while an activated carbon instead of a high dosing of herbicides. So this is activated carbon. So I hope you all understand it. So this is how you will we will deal with herbicide toxicity: optimum dosing, leaching of excessive herbicides through frequent irrigation, organic matter. We will add a farm and manure. We will do frequent tillage. Why? To enhance the microbial action to degrade the residue of herbicides. We will use tolerant crops, herbicide tolerant crops, example maize, sorghum. We will use high amounts of surfactants when we need to do low dosing of herbicides. What surfactants do? They increase the absorption of herbicides. We will use less persistent herbicides, example paraquat, diquat. We will use when you are using 2,4-D, so we will try to keep its concentration below 2 ppm. Okay, so we can, instead of herbicide, we can use non-phytotoxic while activated carbon. These can also help. So this is how we will manage herbicide residual toxicity. Hope you all understand it. Now moving on, although the next topic is not from weed science, but I think I have discussed in detail integrated weed management. So similar, very similar is integrated pest management. Integrated pest management, IPM. So I think if I discuss it here, we can connect the both integrated weed management and integrated pest management, and it will help. These are very similar things. So you can define integrated pest management: approach to manage pests through combining of biological, cultural, physical, and chemical tools in a way to minimize economic, health, and environmental risks. To biological, cultural, physical, and chemical tools to control pests, so reduce environmental reduce environmental risks, reduce health risks, reduce economic risks, as it is less expensive compared to normal or traditional use. So this is what integrated pest management it. What are it aims? To reduce the use of synthetic or chemical pesticides, use of environmentally sound method, as I have discussed, to lower environmental risks. Environmentally sound methods. Pest minimal risks of human health, and also we not to keep any pesticide residues which can also affect human health. Reusable, return on investment. We can reuse these things. And suppose in biological weed control, I will teach a little bit later in detail. We can use dragonfly. So the populations of dragonfly can be reused to eat some pests, and they will provide safe foods with low residual toxicity for us to eat. This is what integrated pest management is. What are its aim? Now moving on to components of IPM. Components of IPM. First of all, we have got biological component. That is use of bio pesticides. We can use insects. For example, dragonfly I have given so many times from the start of the lectures. From when the course is started, dragonfly it's some insects, some pests. So you can use here. There is cultural, to do tillage, this is cultural, to degrade the pests houses, to do tillage before growing the crops. The tillage, what they will do, that they will destroy the established pest. You've got genetical, for example, you can use BT cotton. Chemical, we all know, use of pesticides. Mechanical, use of machines to destroy pests, like deep tilling machines that destroy the established pests. So this is an easy thing. I hope you all understand it, so you can elaborate it as per you. There's nothing, any tough thing in it. Now moving on, one more question was asked: constraints in implementation of IPM. although it is IPM, but you can use these constants in integrated weed management also, but you will little bit change the language there, but the constants in both are same. That's why I am discussing it here in weed science. First of all, there is institutional constant, that is lack of coordination, lack of research, example you can see of farmers neem or neem, lack of research or neem. What lead? We are not using neem as to control pests. We have got informational constant among farmers and extension workers, lack of farmers training, we have got sociological constant, farmers feel it risky to use as there is no proper training. Risky to use. Farmers hesitate to farmers are habituated to use high amount of pesticides, so they are not well motivated to shift to IPM. They are afraid, will it work, will it not work by pesticides, as they are not knowing the side effects. Their pesticide working them for years, so they are habituated, they are not used to leave pesticides. Then we have got economic constraints, lack of funds for training farmers and extension workers. We have got political constant also, vested interest associated with pesticide trade, vested interest associated with pesticide trade. The pesticide industries, they have vested interest and they have some political connections, so they don't want to stop this. Even we have got subsidy on pesticide use by government, so they are not farmers are reluctant to use it. If even you will provide pesticide subsidy on use, obviously they will use it. So they are constants, and you can also use the similar constants in integrated weed management if it is asked. That's why I taught you. Even you can use similar constant in integrated nutrient management also. So I hope you all understand it. So we have finished weed science. Weed science is completed now. We have done it. And for any query, just comment. Like, if you like it, press the like button. Please share and subscribe. This will motivate me to do more better. Thank you. That's all for today. Have a nice day.